Hello and welcome to another exciting Breakfast with Unity. We have dreaded continuity between this episode and the last episode, which is fine. So what we're going to be doing on this episode is opening Unity. Why is that not open? We're going to be making our targeting system work right this time. So first of all, found a little interesting bug / feature of the new UI system. It's very easy to work around, but so first of all, I'm going to set everything up the way that we had it at one point. So I'm going to switch the target box over to this canvas. I'm going to get rid of this sub canvas here. We're going to switch it back to using world to screen point for the position. And we're just going to hit play at this point. So what should happen... why is that going to the corner now? Oh, that's because we don't have that script on here, do we? Yeah. So let's put the script. Actually, let's just leave it in the corner for right now. I just want to show this real quick. So the bug in question is if we change the width and height of this thing, it kind of acts oddly at times, and it's not exactly 1 pixel. This original texture is 1 pixel. We can go pixel perfect, and that makes it look a little bit better. At least it looks even on all the sides. But it's not 1 pixel. And so here's the awkward part. So I'm just going to hit play again real quick. So our site here, if we go to our reticles, no, sorry, it's in third-party license, crosshair 9. If we hit play, you can see that the site is this size. If we change the pixels per unit, say I change it to like 5, it will not change the size. I'm going to hit apply. It will look exactly the same. And that's proper because the UI system isn't using world space coordinates. It's using something else. So it's going to be ignoring this or setting it to some value. And that's what you'd expect. Now, the thing is, if you use a sliced sprite, I'm going to set this to 100 for best practice reasons that I'm going to show you in a second here. So this is a sliced sprite that we have set up so that we can scale it independently. And the problem is, if we go into the game, I'm going to make the target box show up on the screen here a little bit. If we hit play, does that show up? Yeah, okay. So if we go to here and we change this to something low like 5, it will dramatically change the way that this thing renders. It now looks like a plus sign. And if we change it up, it will change how it renders. So what I found is what they're actually internally doing is forcing the pixels per unit to 100. So as a best practice, if you're using something for UI, and certainly if it's sliced, set it to 100 pixels per unit. This will give us glorious pixel perfectness. So this thing now, if we look at it, the target box, first of all, let's go pixel perfect. That'll help. Now if we scale this target box, it's actually a 1 pixel line. You can see that it is 1 pixel wide, and we can scale it at will, and it looks glorious. This is exactly how we want it to look. So, yes, so when you're importing something for a slice sprite, set pixels per unit to 100. So now that we fixed that, we can start making this target box awesome. So I'm going to put the target manager thing on this target box, and we're going to give it the target of the sphere. And we're going to hit play. And so now we have the situation where it follows the sphere. Actually, I want to make sure that canvas is set to pixel perfect again. So now if we hit play, we have this box that will follow our sphere around. So if we move the sphere like left and right, it should move with our sphere. There we go. Now, we can make this thing a little bit bigger to see it a little bit better. Let's just do that. 64 by 64 for fun right now. Hit play. Now I got this big box over it. Now, there's a couple problems that we still have. If we move the sphere around, it will follow where the sphere is, but if we scale the sphere, like if we bring the sphere in closer, it still follows where it is, but it doesn't resize with it. Additionally, if we resize the sphere, it doesn't size with the sphere either. So we're going to fix that right now. So we're not going to need this one anymore. So what I found was I did a search something along the line of get render size on screen, and I ended up with this. And I tried a couple of these things. This one does work, but it has problems where it overlaps the object sometimes. This one works. It has a problem where sometimes it goes outside the bounds a little bit, or looks like it goes outside the bounds. It's actually using the bounds exactly right, but axis aligned bounding boxes, if you turn a box on its size, it looks wider, right? So what we're gonna do is we're gonna use this one, and this one requires a little bit of modification too. So we're just gonna put this in as a function here, copy and paste it, copy pasta, and we can just arbitrarily change this to a transform. That's not a problem, because all they're doing is grabbing the renderer.bounds anyway from this. So we'll just use it as transform. I guess I could rename it. Let's refactor, rename to trans. So at least, whoops, refactor, rename, trans, enter. There we go. So this should work as is, and all we're going to do is we're going to create a rect using this. So rect extent equals, actually we'll call it rect world bounds equals GUI rect with object, and we're going to use our target. Then we're going to set the size. So we're working with something kind of new here. This is a rect transform. Anything in the UI system uses a rect transform rather than the typical transform. And it has a few extra components. It has widths and heights and stuff. And it took me a while to actually find what we needed to change. But what we actually need to change, first of all, we needed our rect transform. So we can get that by doing a private rect transform. We grab it in start as rect transform equals get component rect transform, and now we can do rect transform dot, and the magic one is size delta. This represents the width and height. There's also a dot rect, which is what I thought we were going to be changing, but you can't actually set this as a getter only, and even if you use dot set, it doesn't work. So you need to use dot delta size, or size delta. So size delta equals new vector2, and we're going to give it world bounds dot width world bounds dot height. Hopefully this will work. Let's see if we got this right. So does it compile? It does not compile, because handle utility is a editor class. Move my microphone a little bit back because it's flashing. So we could add Unity Editor, but that might shoot us in the foot because we might not be able to actually export that. So what I'm going to actually do is this is equivalent to camera.main world of screen point. It's just the editor version of it. So I'm just going to take this and we're just going to replace this chunk of text with that in all of these places. You don't need H camera. Oop. All right. All right, save. All right, so if we hit play now, we now have a box and it's sized to our sphere. And if we bring our sphere in closer, it sizes with the sphere. If we resize our sphere so that it's oblong, it stays with the sphere. If we rotate it, you'll see that during rotation it kind of gets a little bit bigger. I'm willing to accept this. This is generally, this effect is exaggerated by how long something is versus how wide it is. So if you have something exceptionally long, this will be more exaggerated. Typically, in typical cases, it's probably going to be fine. If you don't like this, you could always just create an object, just a mock object with a renderer, like a box renderer, oh wait, we need to render it though. You could cull it using the camera. There's ways you could get around this and basically make a object that represents your volume so that you can kind of define, like if you wanted this to always be square, you could set that up that way. So now we have this. This is awesome. Let's go ahead and add our little scale multiplier in here. Why is my microphone flashing so much? I guess I'm louder than normal. We're going to go to scale multiplier and we're going to add this into here. We're just going to multiply our vector2 by it times vector scale multiplier. So if we just save here, we can now make it so like if we hit play right now, the sphere will be, see how it matches the edges exactly. Let's just bring it out just slightly. Let's do like 1.2 and see how that looks. Yeah, that looks good. I like that. So so here we go. So we've got this thing. It's working. Now I think we still have the problem where if we look behind us, we can still see it. I don't know if I'm going to be able to fix that just yet. Oh wow, we're at 11 minutes. So let's save scene, save project. So all right, let's make it so that we can actually target a couple things real quick. And I think I'm going to do one more episode on this because there's one more thing I want to cover that we're not going to have time. So let's actually make it so that we can have multiple spheres and switch between targets. So right now we're just hard coding, well not hard coding, we're soft coding a target here, which we just fill in the editor. So what we're going to do now is we're going to actually make it so that this is a private thing, private, transform target, and I'm just going to set it to null just to be explicit, equals null. As it's private, I'm going to move it towards the bottom of our stuff just so that we stay organized. Boop. And what we're going to do now is, in update, we're going to do a raycast to determine what to actually target. So, we're going to target based on our bore site, and what we're going to do is we're just going to raycast out and add a target. I'm also going to add another public variable. Public layer mask target mask equals -1. This will mean it'll target everything by default, and we can add a layer so that we can only target certain things. So what we're going to do in update is we're going to do if physics.raycast, and we're going to do origin, direction, and hit info is what we want. So origin, direction, hit info. So transform. Actually, we want camera.main.position.transform.position. And the out is camera.main.transform.forward. And out hit is what I'm going to say. And we didn't define hit. That's the reason it had trouble with that. So we're just going to put raycast hit, and we're going to all right. So dog scratching at the door. All right. So physics raycast. Camera transform position, camera, and oh yeah, we wanted a layer mask. So what has a layer mask in it? Distance layer mask, hit info distance, distance layer mask, hit info distance layer mask. So hit info distance layer mask. So we'll do math f dot infinity for distance, and layer mask will be target mask. So now this should raycast out from the camera in the direction it's facing, and if we hit something, we'll do hit dot game object, hit dot collider dot transform. Is there just hit dot transform, or do I have to do collider first? I think I'd have to do collider first. Transform. No, hit dot transform. That works. So hit dot transform is what we want, and we're going to set that to our rect transform. No, not rect transform. Sorry. Target equals hit dot transform. And then what we're going to do is if we're going to make sure that if we have a target, we're going to do it. So if target does not equal null, then we do all this fun stuff. And else, we're just going to we don't want to disable ourselves. We just want to disable our renderer. Can we do that? Canvas renderer. Let's see if just renderer.disabled works with canvas renderer. So renderer.enabled equals false. And that also means that we have to make sure that we set renderer.enabled equals true here. True. And yeah, and let's just do this right at the start, so that if we don't have a target, it will work. Save. I'm going to move our sphere slightly. Oh, we have a problem. What do we have? I missed a semicolon. So canvas, target box, inspector. I want to just move the sphere so that it's not right in the center of the screen. And we're going to hit play. And we see our target box, so that's not a good sign. There's no render attached to target box game object, so we need to use canvas renderer separately. So we're going to do like this, but with a canvas renderer. Canvas renderer. And then we're going to grab canvas renderer. And we're going to do the same thing that we did here, except for it will be canvas renderer and canvas renderer. And then we're going to do canvas renderer dot enabled instead. Let's try that. So if we hit play now, errors. There's no enabled for canvas renderer. Renderer dot. There's no enabled. All right. Not what I. Oh, dot renderer dot enabled. Let's try that. Glad we found that. I think this is going to work. I have high hopes, at least. File, save. So we have compile, we have compile. We put play. Now it's still... There's no render attached to the target box game object. Alright, well, I'm not going to worry about this for right now, then. We're just going to get rid of these, and we'll just... We could park it somewhere off screen, would probably be the best way to do it. Let's just do that real quick. So let's just do what are we gonna do? So transform dot position equals I don't know, vector 3.1 times 10,000.0f. Let's just do that. Save. This will just throw it off in the corner of a screen, I think. So yeah, how did we end up with another sphere? When did that happen? Delete that. Oh, I made a few spheres, didn't I? So I'm just going to delete that and hit play. So now we don't see it. Good. I'm going to turn on our mouse look on our camera thing. We're going to just re-enable this. And I'm going to try and mouse it over this. There we go. We have a target. And it's targeted. Now you see how we have that target drift still? That's really easy to fix. All we have to do is change it so that this happens in late update. So now if we target our... I'm going to put on my mouse look again. Turn it on permanently this time. So there's our sphere. We look at it and bam! We've got it. It doesn't have that drifting anymore. That's awesome. Doesn't that look cool? Alright, so yeah, I'd say this is working. Let's get multiple spheres out there, and actually let's create a layer real quick for targeting. I'm going to create one called targetable. And we're going to just now we're going to go into our target box. We're going to say nothing, only do targetable. And let's create a, I don't know why we don't have a light in here. So let's create a directional light. Let's create a few more spheres so that we can test the targeting thing. And then let's create a cube. And another cube. Let's just do this. And then what we're going to do is we're going to make sure that our spheres are on the targetable layer. And if we hit play now, we should see that we can move around. We cannot target the cubes, but we can target the spheres. And the target switches to whatever one we point at. So I want to show some target info and some more cool stuff next episode. So we're going to do one more of these and play around with them one more time. But just because there's something I really want to add to this that I think makes it a lot cooler. So let's do, just before we finish here though, let's make this target box red so we know that we're targeting stuff. There, yeah. Now you know it's a target box. So cool. Save project, save scene. Thank you for watching. Hopefully you had a good time. I know I did. Did more homework for this episode than I think I've done for any episode. Actually ran into a lot of interesting little problems along the way, and it was just more than we could do in a 15-minute episode, certainly. And I just... The main thing I want to show in the next episode is target info. I want to be able to show like information about our target next to the target, and it looks really cool when we set it up. So yeah. Thank you for joining us. You guys have a great one. If you have any questions, please email me pushypixels@pushypixels.com. You can also tweet me at Drakfire. That's DRAKFYRE. Please donate to the show. Patreon.com/cookingwithunity. We appreciate your support. Donating also gets you access to the GitHub Cooking with Unity super repo, which has a bunch of cool junk in it. You have a good one, and I'll see you tomorrow at 8 a.m. for another episode of Breakfast with Unity. PDT.